Let's put that over, eh? So people can't send me hate mail.
Today on Xenodilodon, something a little different. Here's version 1 of the White Panda. This is an LED helmet that the DJ uses, and we've made a version 2. So what I wanted to do is I wanted to record a lot of the work that I do to share some of the tips and tricks of getting LED installations like this running, so that way you can design your own LED stuff a little bit more. This version happens to be the 144 per meter LED density. However, we've gone to using the 60 per meter LED density. It runs a little cooler, takes a little less voltage, and looks pretty good. So, on with the version 2 build.
Here's what I do when I'm not doing things like YouTube. I'm doing LED installations, and this LED installation is actually for the White Panda. So I've got 2 of these LED arrays that I'm going to be working on, soldering up that I've already put together, and this is for the front piece. This is pretty much what I do. LED and laser stuff like that. Basically, my entire life is putting lights into things that don't have lights in them, and it's a good job. It's a good life. So all these things, I want to quickly just clean up all the ends on here. I love the paste soldering station. Probably one of the best tools to ever use. Get that tip nice and wet there with some of the solder.
The soldering, in compared to the rest of the work, is pretty safe, easy, and therapeutic. I happen to use a Pace Heat-Wise soldering station, which is a 75-watt soldering station and delivers quite a lot of heat to the tip. It's also very lightweight and comes with a lot of other tips that you can look at. The solder that I'm using is by Netcom Lab, and it's a 6040 lead tin alloy with a rosin core. I'm using a 0.8 millimeter solder wire. That's a really, really good solder wire. It's a little bit more expensive, but I definitely enjoy using it, and the results do look amazing. So I definitely recommend looking into that solder as well. In the video, I'll also be showing you how to make a bunch of these little connectors, so that way you can easily make a bunch of them on your own very quickly and hook up LEDs easier.
Okay, so you can see I've finished up all of the LED wiring. I've got the 2 outside leads of each one in parallel for the power buses. You'll notice I have 6 wires, 4 connections. So the outside ones are doubled up just to get some extra power in there. And these are the WS2813s, but with the data in, you can just send the same signal as the WS2811 or 2812B. It's the same 5-volt rail. So I've got a little controller that is actually meant to run the WS2811 and 2812, and it runs the 2813 for testing purposes pretty well. So each one of these are independent panels. And so what I'm going to do is I'm going to test them. And I got the bench top power supply here, which as you can see, it's a little hard to read. But what I'm going to do is I'm going to set that up to about 4 volts. 4.2, 3.8, 3.9. You kind of see there, 3.9 volts. Then I'm going to connect up the LEDs and see how they run, see if there's any problems with them. Get an idea of how well that whole thing went. So, put the power supply down, move the LEDs up, let's test them out. Perfect. So, turn off the light. Well, I gotta wipe the screen off. Alright, so that's what they look like right now. Looks pretty good. I think these 2 panels are set and all wired up, good to go. I'm gonna pop these into the helmet. So at this point, I'm just getting ready to glue in some of the other LEDs. Right now I've got most of the front assembly done. So I'll rock this back and kind of see in there that a lot of the LEDs are in there already. So that whole front section is done. And we'll be laying the other LEDs on the other sides of the eyes. So I'm going to start on this side. Going to line up the insides.
The 2 strips I'm putting in at this moment are guidelines. These will allow me to look at where the geometry for the entire helmet lays in, and I'll be able to gauge a little bit more where the other LED strips around the eyes are going to go after these are laid in.
So here we go. show you what a little bit more of this inside looks like. So it's a really odd geometry of this helmet. So these LEDs here that's wired up, and those all fold into the back. So the inside's going to be taken out, and got the ears right here. They're going to be blacked out. So what I've just done is just lined up those LEDs, and you can see where I pulled the strip back right here. So the LEDs pretty lined up. It's a pretty good indicator of where they are on the strip. And you see the same thing on all the other ones. A lot of soldering. So got these connections. Got to start the wiring here and see where the inlaid plate goes with that. The ears aren't going to get any LEDs at all the inside. So basically this whole section right here is going to be left blank. So now we've got to wire up the LED patches that fill in the rest of the eyepiece here. Of course, keeping in mind that this side is ground, positive ground, positive ground, and on this side is the opposite way. Let's start with the positive side sticking out. Positive, ground, positive, ground. So both backwards. That's to keep data consistent for the programmer. Luckily, I don't have to do any of the programming. He's probably saying the same thing about laying in nearly, about 1,500 LEDs. It's a lot of LEDs. This is one of the LED segments that I'm building, and this guy sits actually really nicely right between the eye and the ear. Just focusing on that. So you can see that the geometry is set to lay in right here in this area. So, and of course I checked it out on the other side. Got to make the other side as well, but I tilt the helmet a little bit, and I'm going to take it. I'm going to try the same geometry on the other side to make sure that things line up evenly. I'm going to flip it the other way just to kind of give it that inside out effect. Flip it this way. Yeah. So same area backwards. If you can see that or not, right here. So the same kind of geometry that fills in the ear area really well. Got to build the other one, but that'll be right there. Looks pretty good. So I'm gonna move the helmet off the desk. Take this. Got to wire up those two segments. I already have all the LEDs for the other side done. Of course, I'm making the invert of that one. Then I got to lay out the panels, the LED strips, not panels, to go the opposite way as they were before. So here I'm starting with the ground, and then ground, 5 volts, ground, 5 volts. So this time I'm doing the opposite. Whatever, low battery mode. Got to plug the phone in, but I'll do that after I verify the pieces that I have. Gluing these together now. Got the strips laid out according to the inverse of this. So if that's all set up and everything else like that, kind of get a good view of what's going on here. I'm going to tell you right now a couple of reasons why I'm using this big aluminum block. Reason number one is that it gives me a hard surface to work on, and it's also a cooler surface. So that means any glue that I apply to the LEDs while working on them, it's going to just cool down a little faster. Number two, second reason is just a safety reason. You're working on a big, cool block of metal. And for those of you who worked with a glue gun, it's way more dangerous than a soldering iron, simply because the solder doesn't stick to you the way the glue does. So I like to work with a firm piece of metal. It's cold, and oftentimes I'll actually have another heat sink on standby. So if I get glue on my fingers, palms, or anywhere else, I can just simply put my fingers or my hand or whatever that I've got that hot glue on against the heat sink. The aluminum's going to be fairly cool. If you're worried about the glue sticking, you light layer oil or whatnot, but usually I've found that the hot glue never really sticks to aluminum very well, especially when it doesn't really have a chance to warm up all that well. So here I got my LED strips all aligned and stuff, so I'm going to be working on gluing them in segments, the way that I did this, just in rows. by holding the LED center as close to a line as possible.
Gluing the LED strips together is probably one of the most tedious tasks to do. It's tedious because you kind of have to sit there and let the glue cool down before you can really move the strip. Otherwise, they kind of fall out of alignment. Other issues are that as the glue cools, the LED strips kind of like to pull in one direction or wander. So you really kind of have to look at it and monitor where the LED strips are as the glue cools. The other thing is you kind of have to watch out for how the strips are laid out, because I'll tell you, it's a lot easier to glue strips together than it is to take them apart once they're glued. So just a little bit of kindness and care and patience, and it looks really good when it's all done. You'll also notice that I also use the soldering iron to adjust some of these strips once the glue is cooled, and it's a little trick to use as well.
So I'm going to fold all these over, and when you're folding these over, you're going to be a little careful with them, so that way you don't bend the area right next to the LED and have that break off. So just little edges, so you get those little edges exposed, and not even a hard bend either. Just kind of make sure that you roll them just a little bit, so not giving them a good crease anywhere along there. It's a good roll on the edge, and then just kind of working it like this.
For more structure, I also recommend putting glue underneath the folds. This helps durability.
This is solder that I use, actually. You can get it off eBay. Honestly, one of the best wire. I paid $26 for 2 of these rolls, so $26 for a pound of this stuff. It's absolutely worth it. Absolutely worth it. It's worth it. Get a good product. Don't worry about spending a little bit more money on it. It'll serve you better in the long run. And on some things, especially when you're doing larger clientele, larger scale things, you don't want to skimp on the little things, because the little things are what makes the difference at the end of the day. So, with soldering, make sure you have a clean tip. This is definitely not a clean tip, so I'm going to wash it off on a little sponge pad. Oh yeah, I got to turn it on first. And my soldering station is over there. A lot of you are familiar with these little sponges. Great, get them a little wet, make your day a lot better. But you can't solder with a tip like this. It's too dirty. And I got some hot glue in it from earlier. Understandable. All right. Now we're ready for soldering.
As my dad says, slow is precise and precise is fast. Do not go as fast as I do while soldering. If you're new to soldering, try to make it look as good as I do, because that's what matters. Making good connections is the most important part.
A lot of it is skill. And a lot of it is methods on how you do things. So as I was talking about earlier, we need to make a whole bunch of these. And so I've got 4 on one side, 3 on the other. Just straight U's like this that I gotta make. And those will actually go really quick due to clever technique. So I'm gonna make a total of 14 of them. So I'm just gonna start doing that. Start making those U's that one. Got a little tool here. Just give them a little crimp.
While working, I encourage you to try to develop your own techniques and innovative ways to do the work. I found that there are a lot of tips and tricks that you can teach yourself, and just looking at how the situation goes together, how the parts go together, and the function, and there's a lot of things you can do to take a lot of time off.
We're going to actually strip all these wires real quick. And as you can see, there's 4 connections per each one. We have over 14, so that's about 100 wires that I got to figure out how to strip. Do quickly to make it go well. So here's my technique. I'm going to turn the soldering iron on. We're going to use the soldering iron and the hot tip. It's been out of focus this whole time. You see soldering iron, hot tip to start stripping these. Move that out of the way. So on every single one of these, all I'm going to do is simply just go down the line on both sides. That.
I strongly recommend using a fairly sharp point on your soldering iron, and as you notice, my voice kind of gets a little robotic as my throat dries out during filming.
You know, I used to think that the physical labor was the hardest part to work. It's really not. The hardest part of what I do, my job, is just that whole creative edge. Figuring out where the LEDs are going to go, where all the parts are going to actually fit, and how it's going to look when it's all done and finished, more so than the actual physical labor involved. So now I got all these done. Now we're going to strip. So check this out. This wonderful crab scissors. But if used incorrectly, it is the most wonderful strip tool in the world.
I think every tool has a main purpose and then a bunch of other purposes. And if you work really hard, you can find those hidden purposes in nearly every tool you own in your workshop.
As I said, I'm a big fan of making things easy on myself by clever and creative thinking, and I just actually thought about this while making this video. So, as you can see, all of these are in segments of 4s. You can kind of see that. I'll zoom in, and each one of these has been bent. So that way the two outer ones are, you can see especially here in the top corner, you can see the two outer ones on each side of the 6 are together, and that's just for extra current carrying capabilities. But I think this is going to be a great way of soldering all of these kind of in bulk. So that way I don't have to worry about holding each individual piece. I could just kind of go at the whole plot as if it were just one unit.
So just another thing, one of my friends, they told me about the Japanese working method. And the Japanese working method is one where the less you have to move your body, the more you can get done. So the concept is to bring the tools and the parts to you and kind of have them around you as part of your workflow. And I've kind of taken that and adapted that same ideology to how I work. And in this case, what I've done is I've taken each part of the wire and I've put it in this heat sink, which allows me to work with all of them. I get to move the entire block as one and inspect it as one. So that means I'm not worried about individually grabbing a piece of wire or handling it. And plus, I don't have to worry about it getting so hot in my hand when I go to solder it. And it's become a really interesting way of doing these wires, and it saves a remarkable amount of time. So I definitely recommend considering this as a tactic for doing these wires when you're doing a lot of soldering for LEDs.
So I got these 2 segments, and I have them connected up to an LED controller. Flip them over, see what they look like on the back side. So here's what I've got right now. So all of these wired up, all nice. And each one of these are independent sides. So put them on a nice insulating material, and we'll see how they look. Let's plug them in. Oh, that looks pretty good. Yeah, nothing wrong with those. I'm gonna turn off the light. We got the first one LED not working. Go figure, man. Pull that LED out and repair it, replace it. Go figure. One LED. Gotta figure. That's hilarious. So I gotta actually replace that LED. Oh, that'll be easy. Let's start gluing those pieces into position.
For this project, I'm using hot glue. It has the advantages of being able to be repositioned with a heat gun later. However, the downside is because these LEDs do not have a heat sink backing, if they're run at full voltage or at full brightness for too long, they will become hot and melt out.
You can see I've got 2 more pieces to put in now. Both of these pieces have been tested. One of these pieces go here, and I got the inverted piece here. So those 2 pieces, one will lay down right in this section here, and the other one will be its mirror, which is going to lay down in this section here. So that'll be all nice and smooth. Those LEDs will lay in just fine. So let's get to gluing these little pieces in.
Now, as I said before about heat, it's typically best to mount these on a heat-sinked material, a piece of metal or something, to wick the heat away that they generate on higher brightnesses. In this case, we're going to overcome that by programming them to go at 80% brightness at max.
I now have the last 2 panels made, These are the bigger panels for the back. So this is quite a big panel of LEDs. And then I've got the other panel too. So these are the mirror image of one another. And now we get to test them to see if they work. I've already got this one hooked up to the Magic LED controller right here. And now I'm putting power to the 12 volt. It's not 12 volt, I'm going to put power to the positive and see if it works. Okay, so turn off the light. I got these set on low, just for power saving, but yeah, that works. That lens is dirty again. I gotta wash out that camera lens. Yeah, that looks better. Okay, so yeah, this one works. Cool. So I'm gonna turn this one off. Test out the other one.
Please enjoy the following bits of awkward silence.
Alright, will it glow or will it blow? Hey, cool. So that whole thing works. Turn it up. Gotten a few failures. Like I think I had one bad pixel, and there was one connection that I needed to redo, but that's it. Of all of these connections, I mean, pretty much it's been a really easy thing to do. It's been an enjoyable work. So I'm gonna get these both installed. All the sections are already in. I put in some other segments since last filming, so there's been a few that I've installed and tested that you haven't seen on film, but you'll see that on the inside of the Panda when I bring that out to put these last segments in. So this is where I'm at with the Panda right now. As I said, I have the last two panels to install in the back. And I'm going to be installing the last two LED sections.
The hardest thing about interesting geometries like this is the fact that the LEDs, when they're put into a strip or a panel like this, don't want to curve or follow the internal geometry. And this is because the curvature is on two axes. So, for example, it's like trying to put a piece of paper flat into the bottom of a bowl. You kind of have to cut interesting shapes out of the paper to make up for the areas where it doesn't want to curve in or flex, which gives us this really bizarre internalized LED panel shapes. So it's kind of like a puzzle that's inside out, which gets interesting.
Look like this from all that work from the glue gun, heat gun, placing those LEDs in. Yeah, it's never an easy job, but here, let's take a look how it looks inside. Give you a full cinematic view of the goods. And then we can start with the master wiring for the power. And start with the data testing just to make sure that all the connections are still good. And of course, exposing all those LEDs with all that heat, I'm sure doesn't help things either. But here we go. So the last two panels that I've connected up are laying right there. So this one on that side, and over there is the other one. And those will be connected. I've also done the wiring on those. So all I have to do is pretty much now do the wiring that connects those two areas. About here. Got those already. Alright, so I'm just about halfway done, a little over halfway done actually, with wiring up this helmet. And I've got the power wires and trying to keep everything just organized for the programmer. Also giving him plenty of extra data wire to work off of when he needs to address the GMX universes. But got about half of this wired up right now, and it should be functional. So I'm going to run testing up to this point, which should be this entire half of the helmet and then the front. So I'm my battery and everything. So this is where I get hesitant. I've already tested it. I had one fault to ground, and I fixed that, and that went pretty okay. So nothing major with that. So no faults to ground, and everything's connected. So theoretically, should be good. So I'm gonna plug that in. Gotta wire up the magic LED controller real quick. This is what I'm using for testing. The little magic LED controller here. See what lights up, what doesn't light up. Nothing is lighting up. But why? Getting power. Data. Looks clear, man. Why are we getting nothing? Why are we getting nothing? Alright, here's the current angle of wires again. So I've had to go through and actually replace some strips. So I've had to replace from that segment down. I've also had to replace this segment as well. But after that, everything on this side in that upper area works. Now, I don't have a high amperage power supply connected to this, so I just have a pair of lithium ion cells. They're 18360s. Worst caveman translation in the world, 18650s. So we go ahead and turn this on. All right, we're gonna show you what it looks like at this point. So there you go. This is at half the helmet, completely wired up, so it looks really good. About 800 LEDs right here running right now, and go around and see what it looks like on the other side. So as I said, the batteries that I've connected up to it, they're not really high drain batteries, and this does take a lot of power, but so I'm gonna go to the first mode, turn down the brightness too, so that way I don't overload it right away. So that's about 1/4 brightness. Auto, red, green, blue, mode 1. So you got the rainbowy mode. All those pixels in there. I don't know if you guys can see it or not, but there. The back. And then here's the front. And then over and around. A lot of LEDs. So I'm going to turn up the brightness. There you go. They look amazing. Alright, so here I've got all the wiring done, all the power wiring pretty much set, and it's all good on the bottom section. So, have everything down here, and I got the magic LED running. So, I'm going to flip this over, and I'm going to show you what this little guy, what that little guy looks like.
So with all the LEDs installed and all the power wiring done, I can now test the entire helmet out using the magic LED controller, and I am very impressed with how version 2 of this helmet turned out. As I said, I don't really program myself. Mostly I'm a laserist by trade, so that's where my talents lay, working with lasers, and I love working with LEDs, don't get me wrong. But I really like working with the analog side of the hardware. So mostly, things that handle power electronics, working with different circuits and setups like that, and then working with installations of just the hardware in general. I want to get a lot of those things out there that people who don't know how to program can look at. So there are different decoder boards for like DMX to SPI. There are different little LED controllers, different Bluetooth and Wi-Fi controllers that will do a lot of things just like this one will do. And they're pretty cheap too on the market. I recommend getting into those if you're learning how to wire up things like this. They're just in general a good thing to have because those little controllers will help you troubleshoot, will help you with little projects and stuff like that. And I'll be using those in some of the tutorial videos and other projects coming up. This is absolute proof that you can make a flashy video without using many video editing skills. So here I'm going to leave you with the finished product. I want to also start making more videos on just things as I do as part of work. I hope you enjoyed this video, and I hope that you've learned some things and it'll help you with your projects on your own. If you have any questions, please leave them in the comments. That way I know what you guys are interested in and learning, and a little bit of how I can help you guys out with your own things. If you enjoyed this video, consider subscribing for future content. And if you want to learn more about our custom prop work created at Collective Designs, those links will be provided in the description below. Until then, stay tuned and have a good day.